So I guess everyone's on board again, so we can start our second session. And to start off, may I call on my other colleagues from the Institute of Feed Science and Mammalogy and Plant Pathology. To serve as a moderator, we have Dr. Susan E. Bakut and the rapporteur, Ma'am Priscilla M. Barshal.
Hello, good morning. Good morning. Okay, thank you. We have a big audience. And for this remaining session of our Research and Development Symposium, we have three young, handsome, beautiful, promising professors who will talk about their research projects. The first speaker will be Dr. Romel Sulabu from the Institute of Animal Science. And the next one is Dr. Amado Angeles from the Daily Training and Research Institute. And the last speaker is Dr. Catherine Israel from the Institute of Food Science and Technology. So without much explanation, I call on Dr. Romel Sulabu, now the present Editor-in-Chief of the Philippine Agricultural Scientist.
Thank you very much, ma'am. Magandang umaga po. Good morning. So again, it's a pleasure for me to be able to participate in this year's CAFS R&D Symposium, and I'm happy to be able to present some of the work that we're doing at the Animal Nutrition Division. So this is a series of projects that I'll be presenting to you. And actually, I was thinking a while ago, my challenge is, I thought it was a 45-minute talk. So, but I think that's the challenge when you have a lot of graduate students. I think the number of graduate students is negatively correlated with eyesight, something like that. So I think I failed to see that it's only 15 minutes. So bear with me, I'll be skipping quite a number of slides. So what I'll talk about is a project where we develop dynamic approaches in estimating the energy value of cassava. We're doing this for different species, but what I'll be talking about today is the work that we've done in broiler chickens. So one of the major challenges that we have in the industry, in the livestock and poultry industry, is the high cost of feed. And that is the major contributor to the high production costs that our producers or our farmers are facing, or the challenge that they have. And one of the ways that we can do that is to think of developing successful feeding programs that will help us achieve higher profitability, good product quality, and obviously environmental sustainability. And a big part of developing successful feeding programs is assessing more accurately the supply of nutrients that we provide to both poultry and livestock. And a component of that is understanding the ingredients that we use in the diets and what factors affect the nutritional value of those ingredients. Now, cassava or cassava meal is not a new ingredient. It is considered a conventional ingredient. But in the Philippines, it is an underutilized material in the feed industry. And there are a number of reasons why. One is when we use cassava to replace corn, one of the most common observations is we don't get the same level of performance. The second is, particularly in the broiler industry, the use of cassava leads to wet litter problems. So when we have wet litter problems, chickens tend to be more prone to diseases, particularly leg problems. And so we went ahead and looked back at cassava as a material. And cassava essentially is an energy source because it's primarily composed of starch. It's about 60 to 80% starch. And it contains very low levels of protein, it contains very low levels of fat. Okay. Now we understand that it is highly digestible as a source of energy. But what we do see is that there seems to be a lot of variation in the quality of cassava. And I think that would be related to the variation in the starch content as well as the quality of starch that we have in cassava meal. And that will also be affected by cultivar for the processing of cassava. The other thing that we also have to understand is how we can mitigate the effects of variability. And one of the ways that we can do that is by developing dynamic models or prediction equations so that the industry can use those models to predict whatever type of cassava they would receive in the feed mill. But unfortunately, there is not a lot of work on that. So we went ahead and did a series of experiments with the objective of developing prediction equations the feed industry can use to estimate the energy value of cassava meal in broilers. And we started out with this project wherein we evaluated two major byproducts of the cassava industry. That would be cassava root meal and cassava residue pellet, which is a byproduct of the starch industry. So yung cassava residue pellet, but basically yan yung peel with some starch in it. And then we blended those two sources to understand how it would affect the energy value of cassava. And that's what we did. So I'll just skip the methodology and proceed to the results. Okay, so this is the analyzed composition of those cassava products. CRP is the cassava residue pellet. And then we have PCM for the prime quality cassava meal. So practically this is about, I believe about 76% starch. Okay. So cassava residue pellet is about 55% starch. So which means na hindi talaga fully nare-remove yung starch fraction from the peels. Okay. And as we already expect, it is higher in fiber compared to the prime quality cassava meal. Now those two sources, we blended it, 75% CRP and 25% PCM in the first blend, and then 25% CRP and 75% PCM. So we have increasing levels of PCM in these four cassava products. And when we evaluate the energy digestibility of those four sources, what we observe is we see a linear increase in energy digestibility. And as we would look at the energy value of the diet, we also see an increase in the energy value of the diet as we increase the proportion of prime quality cassava meal. So this already indicates the negative impact of the peel or the fiber fraction on the energy value of the cassava blend or cassava product. And that's what we see here. This is the energy digestibility of the cassava diets. So when we measure the energy value of these ingredients, the cassava residue pellet, the energy value or nitrogen-corrected AME is around 3.009 megacalories, while prime quality cassava meal is more than 1,000 kilocalories greater than what we have in CRP. So this already would tell us that fiber content or fiber composition of cassava meal would be an important indicator of the energy value of cassava meal. And that's what we see here. As the crude fiber content of the blend increases, we see a negative effect on the nitrogen-corrected AME. So from here, we could already think that we can develop prediction models by just looking at the fiber composition or fiber content of cassava. And that's what we went ahead. And that's what we did in the second experiment. So in this experiment, we evaluated 14 different sources of cassava meal that we sourced. Mostly, half, I think, came from the Philippines and half came from Thailand. And all of these raw materials were actually provided to us by the industry. So we have 14 sources. You'll see the source. So we have quite a number of cassava meal products coming from Thailand. And all of these sources were obtained from the feed mill because we want to evaluate material that the industry is already using. Okay? So tapioca chips that come from Thailand, most often they are peeled. So they remove the peels. And then most of the cassava products that come from the Philippines are unpeeled. Okay? And I think all of us would understand why that would be. Because it's It's very laborious and it's more expensive to peel cassava. Okay. And then you have the fiber content as well as the starch content of all of those ingredients. Okay. So when we look at the nutrient composition of those 14 sources, so we have here the descriptive statistics. So gross energy is about 3.66 megacalories, and that is higher than most of the published values for cassava meal. But what is very interesting here is the variation. So the lowest is 3.47, the highest is 4.06. Now, in terms of the starch content, the average is 67%, which is similar to most of the published values. But again, the important thing here is the variation in the starch content. So the lowest was at 49%, the highest was 75%. So just by the variation in starch content alone, that would already indicate to us that there will be variation in the energy value of cassava meal. Now, another important thing here is the fiber composition. For ADF and NDF, we see very wide variation among the different sources of cassava meal that we used in this study. So when we measured the energy value of these 14 different sources, this is what we found. The average is 3.245, and that is greater than most of the published values. But the range, again, the range is from 2.7 to a high of 3.7. So think about that. If we are in the industry, what we often do is we will only use one value for one material. So let's say for cassava meal, if this is the published value, we will formulate diets with cassava meal at an energy value of, let's say, 3,200. If I'm using that, and then I use a cassava meal source that actually has higher energy value, that means I'm underestimating the value of that material. That means that would then lead to lower performance. And if I'm using 3.2, but the actual value is 2.6 or 2.7, again, that means I'm overestimating the energy value of cassava. And that would lead to variation as well in performance. So this highlights the importance of developing methods on how we can more accurately predict the energy value of cassava that comes in to the feed mill. Okay. So the first thing that we did was we looked at correlation in among the different components, chemical components of cassava with its energy value. And what was interesting here is that we didn't see any correlation with the AMEN of cassava and its starch content. What is a good predictor was crude fiber as well as the ash content of cassava meal. Now, ash is important because in the drying of cassava meal, most often they are dried, sun-dried. So alam naman natin, pag yan ay nadadaanan, nahahaluan na rin yan ng alikabok. Ayan, dagdag minerals daw. But to us, that has no value. Okay. So, there's a long process here, but this is what we ended up with. This is, we developed what we call UPLD prediction equations, and this is for all raw materials that we are evaluating now, and this is for cassava meal, and we were able to come up with two optimal models. One, a very simple model with crude fiber as a predictor, and then a more complex model where you have more components, and that is a more precise model actually that we could use. So this is something that we could then recommend to the industry, and one of the things that we are trying to develop are what we call calculators. So for example, this is a calculator for cassava meal. So what the nutritionists in the industry would simply do, once I get cassava meal, I will have it analyzed for crude fiber. I will plug in the value for crude fiber as well as the dry matter content, and then I will get a predicted energy value that I will use to formulate the diet. Okay. So that's what we're trying to do. Now, as I mentioned a while ago, what we found in the study was we didn't find any relationship with the starch content and the energy value of cassava. And that was, we were quite curious about that. So we went ahead and looked at the starch properties of cassava and if that would have any relation with the energy value of cassava meal. And so in this study, what we did was we used 4 different sources of cassava meal. We have peeled and unpeeled. And then we also wanted to evaluate the impact of adding exogenous alpha amylase. If adding alpha amylase in the diet can increase the energy value of cassava meal, particularly high fiber cassava meal. So in this study, first thing is when we look at the starch content, we see greater variation in starch. One here is it's quite clear that the peeled, as we expect, is higher in starch content compared to the unpeeled cassava meal. And then we look at the amylose and amylopectin concentration in cassava meal. And what we found, on average, the percent amylose is around 7%, and the amylopectin concentration is about 59%. So when we look at the amylopectin to amylose ratio, we see a range from a low of 6.7 to a high of 10.12. We also did, we looked at pasting profile. We see variation in pasting profile among the 4 different sources that we evaluated, and we used the values that we were able to gather from that from that part of the experiment and looked at its relationship to AMEN. And what we found was that the pasting value was actually a good predictor for AMEN. And I think this is something that we want to explore further, because in this experiment we evaluated only 4 samples. The fact that we did see positive correlation between these 2 variables, I think it's something that we would like to do, add more points to this model. And then the impact of alpha amylase. Addition of alpha amylase did not improve the energy value of cassava meal. Okay. Finally, we have to do a validation test. So once we were able to develop a model, we then used that models to formulate diets to validate the equation. And in this experiment, we used 3 different sources of cassava meal with varying levels of food fiber. And then, using the prediction model that we've developed, we predicted the AMEN of cassava meal. And these were the predicted AMEN of those 3 sources. And then we used that to formulate the diets. These are the levels of cassava meal that we used in the broiler diets at the different phases. The standard here in industry, they do not use cassava meal. So the fact that even just 10% is already a big, and if we find that it's actually good, that's already a big accomplishment for us. Okay. So we use 10% in the booster phase, 20% in the starter, 30% in the grower, and then 40% in the finisher. And what we found was in all phases, we didn't find any significant differences in body weight. In fact, at day 7, birds that were fed the cassava meal with 4.5% fiber had higher body weight than birds that were fed the standard diet, which is a corn-soy diet. And then overall performance, gain, feed intake, and feed efficiency, we didn't see any differences. Although here, we do see that the lower fiber cassava had tended to have higher feed efficiency. And I think that is because when we developed the model, we had more samples coming from this end. We had very few samples that came from this end. Okay, so one of the things that we need to do then is we need to add more points. We need to add more cassava meal samples with very low fiber. We'll add that to the model to make it more robust. And then obviously we have to do diet economics, and what we do see here is that you can actually increase the economic return with the use of cassava. So this is quite a big improvement. It's about a 3 peso increase in margin over feed cost by just simply using cassava. Okay, so the overall conclusion of these projects, one, we were able to establish that there is wide variability in, not just in chemical composition, but energy value of cassava. And what we found was that fiber as well as viscosity parameters are the strongest predictors of the AME and of cassava meal. And these are things that probably we could look further. And then cassava meal can be effectively included in broiler diets using the predicted AME values. So I'd like to end by acknowledging the work of our students. It is not my work, it's the work of my students. Ako lang yung nagsasalita, pero ang nagtrabaho niya ay mga estudyante. So I would like to thank my PhD students, Rona Reyes, my two MS students, Putya Akini from Cambodia, and Hazel, who works for San Miguel, and then supporters from the industry that has helped us fund the project. UPLBFI, PARFI, also I would like to thank. So with that, thank you very much, and if you have any questions, I'll be happy to answer.
We are now open for the answer and for the question and answer.
First, congratulations for the students who made very good research on this one, and to the speaker, of course, who make it more understandable. My question is, what is the cost difference between utilizing the field that is imported, including everything, and the unpeeled? Because I was just looking at it as a sustainable source of cassava.
Yes. First, I'd like to share with you the current situation now. Currently, and I'm sure some of you would already know, corn prices are picking up. In fact, there are areas in the Philippines now where corn is at around 19 pesos per kilo. I was just in Iloilo a few days ago. It was already around 19 pesos per kilo. Cassava, on the other hand, is around 11 pesos. So if I was a feed, if I make feed, that should be a no-brainer. But even with that price difference, feed mills still will not use cassava. There is really apprehension. And that's what we're trying to do. We're trying to change their views on the use of cassava meal. And with these projects, I think hopefully this will help encourage them to use cassava meal in their diets, because it will really help our farmers, because that would significantly reduce prices of feed. Now, the prices between the peeled and unpeeled, currently I am not not sure how much would be the difference. As far as I remember, it's somewhere around 3 pesos. Around 2 pesos difference between the peeled and the unpeeled. Obviously, the peeled cassava meal is the more expensive material. Yeah.
Okay, the second question is, do you have studies on, in Mexico, most of the livestock and pork industries, I think they use more of sorghum and corn. But
Yes.
I think more of sorghum rather than so do we have a similar pattern that we could
Yes.
use? Or?
Actually, personally, I have done a lot of work with sorghum, and that work tells us that you can completely replace corn with sorghum. The challenge with sorghum is more on the processing side, because it is much more difficult to grind, and so many feed mills do not have the capability to grind the sorghum. So kailangan nila ng ibang klaseng hammer mill para mag-grind siya, o kailangan nila ng roller mill to grind sorghum. But other than that, you can effectively use sorghum as a replacement for corn. The challenge also is we don't have sorghum, or we don't have a lot of sorghum for the industry to use. We really wanted to solve the problem of corn, because corn, as we all know, is half of the diet, and it is an expensive material in the Philippines. In fact, the local corn is more expensive than importing corn from the middle of Iowa. So imagine how that impacts the livestock industry. So we're really trying to identify materials that we could use to replace not just corn, but soybean meal. In fact, the way we approach it now is we have to think out of the box. Because our belief is, in the next few decades, the diets that we will have, would be entirely different. It will not be corn soy diets. It will not be wheat soy diets. It will be made up of entirely different material, maybe something that we have not looked at. Maybe yung algae, yung kanina. We're now working a lot on seaweeds because we believe the future of the feed industry is not grown on land. We believe it is grown in the ocean. Yeah. So those are some of the things that we are already looking at.
I have to stand to do the CV. Again, kudos to Dr. Sunabo. I thought this is another excellent paper which simply demonstrates that UPLB ay talagang nilabas sa aghan. Let us give a big hand to all our scientists. All right, the second point, Dr. Sunabo, is that I am very happy and proud that part of his studies we managed to fund through PARPI. And I am very proud again that the Chancellor said that the OWA between PARPI and the university is almost done, which means that for those who would like to fund at PARPI, you are more than willing and we are accepting you without any hesitation. And now, for a more serious thing to say, yesterday there was a very passionate presentation by Dr. Garcia from the Agricultural System Institute with respect to gapping of cargo. I think my question is, maybe this request, maybe Dr. Sunabo, you should do some study to predict the energy values of gapping of tornado, because this is another roadmap that will be very useful. Okay, finally, in Amsterdam, if you go to the ports of Amsterdam, you will see boatloads and boatloads of cassava pellets coming from Thailand. In other words, if the livestock industry and poultry industry in the European Union is using cassava, maybe there is something in cassava that we still do not know. In other words, why would they keep on importing this in addition to what they import from the US? And the bottom line is that we have so many things that we can study here, and I think the predicting energy value, as presented by Dr. Serrano, will be very, very useful to the feed and livestock industry in the Philippines. Thank you.
Thank you, sir.
Any more questions from the audience? Okay, it looks like there's no one else who would like to give a question. Sir, I would like to give a feedback.
Yes.
I'm involved in a research team conducting research on cassava, and your research is very good technology. But the next question will be the production side, the supply. Now, DA is campaigning for the increased production of cassava. Now, the cassava farmers whom I interviewed from Luzon, from Visayas regions, they were really encouraged because of the high price of cassava. For the unpeeled, right now, it's I think 9 pesos to 10 pesos. Now the problem is, after a year or 2 years of going into cassava production, and then the decrease in price, SMC. The reason is that, which they are giving to the farmers, high ash content, high moisture content, and so very low price, as low as 6 or 7. So they are again going back to corn production. So I think these are issues that should be addressed by our research in a way that if we want to go into alternative fields, then holistic yung pagtingin natin.
That's right. Actually, if I would comment, so that's one of the challenges, actually, In the Philippines, the only one that's really using cassava is San Miguel.
Yes.
All other feed companies do not use cassava.
Yes.
So that's why they have a command on the price.
Yes.
And that's what we want to change. If we can encourage more feed millers, farms to use cassava, then I think that will help on the price side. So clearly that is definitely one of the things that needs to be addressed.
So this research in the one led by biotech, it's not only on the roots.
Yes,
but
as also the leaf.
The leaf as
Yeah,
an
yeah.
alternative source.
Yes.
Thank you po.
All right.
So, okay, so thank you.
Thank you.
Dr. Sulabo, we call Dr. Labios, Dr. Villanda to give the certificate of appreciation. Thank you, Dr. Sulabo. So for our next presenter, we call on Dr. Amado Angeles, the Director of the Dairy Training and Research Institute, to talk about in situ dry matter degradability of banana stalk and water lily in their house.
Salamat po. Hello. Hello. All right. Magandang umaga po sa inyo. No, good morning. This project is actually funded by the ABAR. No, it is a collaborative research. To me, it's more of a commissioned research. No, bigla na lang kumumpas si DA Secretary, sabi niya, ang dami nating water lily, nagkaklag yung ating mga river, creek, yung Laguna Lake, Ligwasan Mars. And of course, dahil din yung secretary natin ay galing sa Mindanao, siguro marami siyang kaibigan na nagtatanim ng saging. So yung saging ay walang gamit. No? Although meron namang gamit na konti. The same way, yung water lily ginagamit ng ilan, no, ng mga entrepreneurs dwelling with handicraft. No? But to look at the data, how much of these materials being used by those small industries, medyo malaki pa rin po yung hindi nagagamit. No? I would like to thank yung unang mga speakers, no, na i-emphasize na paliit na po yung pasture area. No? In 1970s, according to some literature, we have something like 2.1 million hectares of pasture areas. And in 1991, 1.2 na lang. Ngayong 2017, I did my calculation. Hulaan nyo kung ilan na lang. 0.8 hectares. Nasa 120,000 hectares na lang po ang pasture area. And so, yung sinasabi po ni Dr. Sulabo, no, yung if we look at animal production, particularly ruminant production, we utilize horizontal space. 1 animal per hectare, 1 mature animal per hectare. So, pag maliit na yung hectareage mo ng pagalaan, no, ng baka, liliit din yung number of animals mo. All right? And so, pupunta tayo dun, sabi nga, sa dagat. No? Huwag muna kami sa dagat kasi walang water lily sa dagat. No? So better, no, if we will be able to come up with technologies that will utilize not horizontal space, but initially vertical space. Uy, saging. Pataas kasi yung dry matter ng saging, di ba? Better kung walang space at all na lupa, yun yung water lily. wala ng lupa, punta ka doon sa dry matter that can be sourced from what? Lakes, no? So on. So, yun po yung logic nung study. And dalawang DA agencies, PhilFIDA, Philippine Fiber Industry Development Authority, and Philippine Carabao Center, tatlong universities, UPLB, D3, tayo po yung lead, USM, and PSAU. So may kanya-kanya kaming toka kung anong species. No? Yung PhilFIDA will work on the potential of banana, although marami ng studies on its use sa fiber. And yun namang USM will work on the survey, no, that will quantify how much water lily or banana stalk, no, or pseudostem can be used for animal feed. And then we have PSAU that will also work on a survey that will quantify how much of this material can be used for ruminant feeding. So, yung ipapakita ko po sa inyo is partial lang, no? Sabi nga po ni Dr. Sulabo, kami po sa Animal Science naghahanap ng paraan para po yung mga product o byproducts na hindi natin kayang kainin, no, ay ipakain natin sa hayop and make them, sorry to say, no, sila yung bioconvert, concentrate ng nutrients. Masarap nga naman talaga ang inihaw na masarap din yung gatas namin, no, kahit paano. So, with them, we should be able to utilize those biomasses that we cannot use. No? And so, in determining the feeding value of a particular ingredient, ang una dapat nating malaman, ano ba yung sustansya meron doon? And then, susunod na tanong, kakainin ba? Susunod, pangatlo, matutunaw ba? Mako-convert ba from that particular nutrient into essential products? And ang susunod pa, wala ba siyang toxins that can bioaccumulate? So, tatanong nyo sa akin yan mamaya. Water lily, heavy metals, etc., etc. Alright, ito po ay picture sa isang area doon sa Ligwasan Marsh na naiipon, no? According to one data from DPWH, ang dami nilang nakukuha, no, para madeklag yung area na to. I think yung data nila from January 2017 up to May 2017, they were able to collect 5.2 million cubic meter of water lily. I think sa Mindanao po Opo. And so, with that calculation, nung kinalculate ko, parang it can feed something like 100,000 heads of mature cattle, kung ganun karami. No? So, may potential siya. Kaya lang, of course, yung ating apprehension on yung possible, although the analysis of the material may not tell us na negative yung content, but of course, the next question will be, chronically feeding the animal will result probably in bioaccumulation. So what we did was to get samples, no, of the material. Banana stalk, although ayaw po kasi ng DA bar na palitan to pseudostem, kasi technically sa atin pseudostem yun, pero yung stalk kasi mas kilala nila. So hindi na lang namin pinalitan, hindi na kami nakapag-away. Of course, water lily, yung Eichhornia classipes, the predominant type of water lily we have. So, what we did was to get samples, and then with the technology that we have at D3, at IAS, no, preliminary study na ginawa namin will be, of course, nagkanda kami ng acceptability. Kinakain naman po siya, although hindi ko na ipakita dito sa data nito. Kinakain ng baka. Next step will be to determine kung yung dry matter, no, ng water lily, which is the dry matter fraction will contain the nutrients. So preliminary lang po, yung dry matter ba ng water lily at banana stalk ay matutunaw nung rumen nung baka. Okay? And so, although hindi pa po kami gumagawa ng economics, kasi sa ngayon, parang ang calculation namin, dahil small volume lang yung collection namin, baka 5 piso per kilo yung water lily. Kasi sinasakay lang sa motor, sinasakay lang sa jeep, kaya mahal. Alright. So, we did proximate analysis. So ito po yung lumalabas, ito po yung benchmark natin na Napier, no, kadalasang pinapakain ng ating mga farmers. So if you look at the nutrient content, crude protein, medyo yung water lily medyo hindi naman malayo, no? Sa Napier, of course, yung banana stalk mababa kasi puro tubig. Fiber, hindi naman masyadong malayo. Yung fat content ay, of course, medyo mataas, no, ng konti yung dalawang material. And ash ay hindi rin ganun ka layo yung values. We sent 15 samples, no, ng water lily at lahat po dito, analysis for cadmium, for lead and mercury, negative naman po yung lumabas. Nung material. Po. All right. So what we did was to cannulate 3 animals, 3 high-producing cows. So para po makita natin yung impact ng quality ng feed na ipapakain natin, dapat yung animals na gagamitin natin, yung high-producing cows. Cannulation po, maglalagay ng butas po, sa rumen. So nilagyan namin ng butas yung 3 high-producing cows namin, and it took around 6 weeks to 8 weeks para makarecover. And wag po kayo mag-alala kasi ito pong mga cannulated animals namin, sila po yung mga high-producing ngayon. Ibig sabihin, hindi po naka-apekto yung cannulation sa productivity ng animals. Alright, so what we did was to get sample of the material. Kawawa naman daw. Masaya po sila, pasyalan niyo po kami sa D3. Nag-grind kami ng samples, nilagay namin sa nylon bags, no, indigestible bags, and then in-incubate po namin yung samples sa loob ng cannula, sa rumen. No? And then we incubated samples at 3, 6, 9, at 12, 24, 48, 72 hours. So parang through time, nababawasan yung dry matter kasi nadadigest ng microorganism. So what we need to know is ano ba yung pattern ng disappearance ng dry matter doon sa sample. Meaning, pag nawawala yung dry matter, baka gusto ng microorganism. Although hindi pa masasagot yung tanong na nako-convert pa siya sa gatas o nako-convert pa siya sa body weight. Wala pa po kami doon sa stage na ganun. So what we did is to feed Napier or to incubate Napier, water lily and banana stalk, in 3 animals with 3 periods following a 3x3 Latin square design. So lahat po ng treatments, yung 3 material na yon will be exposed to the 3 cannulated animals. I-rotate lang namin yung material doon sa animals. So pagkatapos ng incubation, kinukuha namin lahat, no? And then hinuhugasan. Dito po sa study na to, dry matter lang yung papakita ko, pero meron po kaming crude protein degradability, fiber degradability, crude protein, and fiber degradability. So, pagkatapos nun, we air dry, and then put it in oven to get the dry matter retained dun sa loob ng bag. So, ito po yung result, no? Very quickly, if you look at the curve from 0 to 80 hours, ang critical po kasi ang tinitingnan namin dito yung first 24 hours. And based on this is the dry matter degradability incubation time in hours. And if you look at the result, wala namang difference yung fractions. We have what we call rapidly soluble fraction, slowly soluble fraction, and potentially digestible fraction. So if you compare the values, wala pong pagkakaiba with Napier, water lily, and banana stalk. So meaning, baka po pwede. Although we still have to determine kung itong degraded, no, ng microorganism na dry matter na to will be correspondingly convert to maybe milk, no, or meat. So with the values na nakikita natin, wala pong pagkakaiba yung different fractions of dry matter the way the rumen microorganism digest the dry matter present in the material. All right. So as a summary, most of dry matter was degraded during 24 hours of incubation. Dry matter degradability was the same among banana stalk, water lily, and Napier. And banana stalk had more rapidly soluble fraction. Well, hindi ko na isama, no? Ba't nagkaroon CP dito? Compared to water lily, relative to Napier, which is common basal forage diets for dairy, banana stalk and water lily can be potentially a source of dry matter for our animals. So, sa dairy lang po itong nire-report ko, but we have data for goats, for buffalo, PCC po yung gumagawa nun. And siguro in 6 months' time, we will be able to have all of the data, and probably we can share it to you. In addition to this, marami pa po kaming ginagawa doon sa material. Like, we're going to determine secondary compounds, saponins, tannins, oxalates, additional heavy metal analysis, probably arsenic, no? Kasi yung concern ng lake for arsenic. And then, pag ipapakain sa baka, kailangan mo ring i-test yung gatas, yung meat, para makita natin na wala bang bioaccumulation although hindi detected doon sa material, baka naman through time, nag-a-accumulate naman. No? And so, prior to recommending its use, dapat meron po tayong mga ganong test para masabi natin na probably it's one of the potential source of nutrient for our animals. So with that, thank you very much po. So yung po aking ang tawag po namin ay banana lily team. Banana lily team. So si Dean Supangco po kasama namin. Yung mga RAs ko po naandyan sa likod. Thank you very much. O yung banana lily team, tumayo daw kayo. Si Miss Manulat, Miss Abes, and si Tita Ioni. Tayo ka, Tita Ioni.
Okay. Thank you, sir, for the research, excellent research. Kahit yung iba ang sabi, kawawa naman yung mga hayop. No? So, we now accept questions.
Siguro sabi niyo, sino ba itong tanong natin? No, I just want to share on the title, the water lily. Alam niyo, muntik na akong bumaksak sa defense ko ng master's thesis ko. Kasi, water lily Eh, yung pala, yung aking teacher, yung aking advisor, ang sa kanya ay, ang sinasabi ko ay, ito, kilala ko na siya water lily. Ngayon, lahat tayo water lily. Pero actually, water hyacinth.
Yes po.
And kaya, ang sabi niya, what? You are using it only for, you're just wasting it? It is very expensive in Thailand, Remember the lilies that they get so many products that are expensive, including yung ating mga blossom dyan. Those are lily flowers. Kaya, I just want to share that probably for international publication,
yes, sir.
Probably we should put the scientific name.
Yes, sir.
Pero ang water hyacinth, the way I was corrected. Okay?
Thank you, sir. Yun po, tama po yun. Kapareho po nung banana shoes stem, we were proposing water hyacinth, pero mas gusto, alam mo naman yung popular, gusto nila yung popular na name. Ayaw nilang palit. Saka na naiintindihan natin, pag nag-publish na lang kayo, saka nyo na lang baguhin yung pangalan. Opo. So that's water hyacinth na Icornia crassipes.
Any more questions, sir?
Talagang kilabot siya kam ang mga taga-UTM. Palakpakan muli tayo kay Dr. Angele, my question is, yung analysis na walang lead at saka cadmium, baka naman yung mga sample ninyong kinuha yung malayong-malayo
Yes, correct po. Part of the study, no, is to collect po from different areas kasi dapat representative. But to be related, no, to the study, yung pong pinadala ng naming samples, yun talaga yung pinapakain namin. Kasi po, initially, napakamahal po kasi ng heavy metal analysis. But dahil si Dr. Agbisit po ay naka-acquire na, no, through a donation from a private company ng isang AAS, probably we can analyze unlimited number of samples para po makover namin yung... Kasi ito, nanggaling lang po sa bayan yung sample namin dito sa banda, Los Baños area lang. And I have a student that will get samples from different areas ng Laguna de Bay. Yun pong 5 samples, nanggaling po yun sa USM, yung 7 nanggaling sa Pampanga. Kinukuha po nila yun dun kung saan kumukuha sila ng pinapakain nila dun sa kanilang mga experimental animals. So dito po sa atin ay 5 samples lang I think yung napadala natin.
Ibang pinapainom sa amin. So,